Welcome to MindXY, your channel for logical thinking and puzzle solving. We have two identical squares. One is fixed. The other has its vertex pinned exactly to the center of the first one. As I rotate this second square, the shape of the overlap changes wildly. The question is simple. Does the area of this overlap increase, decrease, or stay the same as we spin it? Let's freeze the frame right here. The side length of the square is 10. The angle of rotation is, well, let's say it's an awkward 17 degrees. Using only geometry, calculating the area of this strange, irregular quadrilateral seems like a nightmare. You might be tempted to reach for trigonometry. Pause the video here. Can you find the area of the orange overlap? Is there a way to solve this without knowing the exact angle of rotation? Trust me, the answer is simpler than you think. Let's look at the easiest possible position. If we rotate the square so its sides are parallel to the main square, the solution is obvious. The overlap is exactly 1/4 of the main square. Since the total area is 100, the overlap is 25. But does this hold true when we rotate it? This is where the magic happens. Look at these two triangles. When the square rotates, it loses this orange triangle on the right, but it gains this white triangle on the left. If we can prove these two triangles are identical, congruent, then the area hasn't changed at all. We can prove it using angle-side-angle. The central angles are related by rotation. The distances to the edge are identical. This means the triangle we gained is an exact copy of the triangle we lost. We can literally cut the new piece and paste it into the hole. This proves that the area is invariant. It doesn't matter if the angle is 17 degrees, 30 degrees, or 89 degrees. The overlap is always exactly 1/4 of the stationary square. The answer is simply 25. Symmetry is often more powerful than calculation. If a problem looks too hard to calculate, check if you can rearrange the pieces to make it easy. Here's a question for you to ponder. We pinned a square to the center of a square. What if we pinned an equilateral triangle to the center of another equilateral triangle? Is the overlap area constant as we rotate it, or does the magic break? Let me know in the comments. If you enjoyed unraveling this mathematical mystery with us, hit the like button and subscribe for more deep dives into math and science. Let us know in the comments what other puzzles we should explore next. Thanks for watching.